All right, welcome back. Today we're going to take a look at quadratic problem solving. We'll look at some various ways that we can solve quadratics in real life. The majority of those are going to be related to geometric figures in some way, shape, or form. Question number one is just that example. We have a rectangle where the length of that rectangle is 6 inches more than the width. So we'll translate that back into a mathematical problem, and I'm just going to go ahead and label this as the length and call it the width plus 6. And then the width remains unchanged. The area of the rectangle is 91 square inches, so I'm going to put that on the inside. Area equals length times width. Area equals 91. So I'm going to use substitution here, and I get W times W plus 6 equals 91. And I use distribution here to get this simplified into a factorable form. W plus 6W equals 91. Subtract 91 so that I have my quadratic in standard form. Minus 91 equals 0. Now what I'm going to do is I'm going to go ahead and factor this, and the two numbers that multiply together to make negative 91 and positive 6 are going to be 13 and negative 7. So the factored form of this becomes W plus 13 and W minus 7. Following that, I'm going to set each one of these equal to 0 and solve for W. And with real life, we have restrictions, and the negative values cannot be used because I cannot have a negative length or a negative width of a real life object. I'll be using W equals 7 as my solution. Negative 13 will not work. So 7 plus 6 is 13, so the length of my rectangle is 13. Example number 2 involves a right triangle, so I've gone ahead and drawn in my right triangle there. I'm going to label all the parts of my right triangle so that I can solve this problem for the value of x, which is the unknown length. I'm asked to find the shorter leg, and all of the other sides of the triangle are based off of the shorter leg. Notice the hypotenuse is 6 more than the shorter leg. The longer leg also longer than the shorter leg. So I'm going to call the short leg x. That makes the hypotenuse, which is always opposite of the right angle, x plus 6. And that makes the long leg x plus 3. I'll utilize Pythagorean theorem to solve this problem properly. A squared plus b squared equals c squared, so I get x plus 3 squared as b, and then I get x plus 6 squared as c. I'm going to go ahead and multiply out these perfect square trinomials. X squared plus x squared plus 6x plus 9 equals x squared plus 12x plus 36. I have more x squareds on the left side, so I'll be moving everything on the right side to the left side to set this up in standard form. Line up and combine my like terms to give me my factorable quadratic. Looking for the two values that add up to or multiply together to make negative 27 and add up to negative 6. That'll be negative 9 and positive 3. The factored form of this becomes x minus 9 times x plus 3. I'm going to set each one of them equal to 0 and solve for x. And again, in real life, we cannot have negative side lengths of real life objects. So our final answer is going to be x equals 9. Now let's reread the question to make sure we've answered what has been asked of us. That's a very important thing when it comes to quadratic problem solving. It says find the length of the shorter leg. We've identified the shorter leg as x. We've identified x as 9. We can plug into the others to find any of the others. So in future questions, if anybody's looking for those others, just go ahead and answer what's being asked. All right, question number 3 involves some logical reasoning that for some is not always apparent. So the first thing I'm going to do here is I'm going to address what 2 consecutive odd integers actually looks like so that we can start to develop a pattern to figure out how to solve this problem properly. So if I choose the number 1, the next odd integer is 3. If I choose the number 5, the next odd integer is 7. Now what I'm going to do is I'm going to make a general statement, and I'm going to say that the odd integer I have right now is the value of x. That means that I've got to figure out what the next one is in terms of x. So let's use the pattern we have so far. So to get from 1 to 3, I have to add 2. To get from 5 to 7, I have to add 2. So that means in order to get from x to the next odd consecutive integer, I have to use x plus 2. So now what I can do, now I've identified what my 2 variables are going to be, that's x and x plus 2, I can now answer the question that I'm supposed to ask. Answer: the product of 2 consecutive odd integers. Okay, so let's multiply those together. X times x plus 2. Is my key, that's my equal sign. 1 less than, that's my backwards translation, so I'll put it out here at the end. 4 times their sum. So sum means add, so I'm going to multiply and then add them together, x plus 2. I'm going to simplify here and here using the distributive property. So I get x squared plus 2x equals, that's 2x plus 2, so that's going to be 8x plus 8 minus 1. I've got my x squared over here, so I'm going to move all these over. So it's minus 8x, combine like terms, that's 7, so minus 7. Minus 8x here, and then of course the 7 can't combine with anybody, so he kind of goes off by himself. Okay? So now I'm going to get x squared minus 6x minus 7. Now I'm going to factor that. What 2 numbers multiply together to make negative 7 and add up to negative 6? Well, it's got to be negative 7 and positive 1. So that becomes x minus 7 times x plus 1. All right, set them both equal. X minus 7 equals 0. X plus 1 equals 0. X equals 7. X equals negative 1. So now what we have here is we have a situation where there's no restriction on which integer I'm supposed to use. So I can either use the 7 or I can use the negative 1 as my starting point. So let's go ahead and start with the smallest one. So if I start with negative 1 as my starting point, the next consecutive odd integer would then be 1. So one possible answer would be negative 1 and 1. If I start with the number 7, the next odd integer would be 9. So another possible answer would be 7 and 9, because it asks for what the 2 odd integers were. So it's either going to be this one or that one. On a test, if you're given a problem like this, you will be given specific instructions on which one or which ones to give. All right, the final one that we're going to look at here involves a picture frame that's being matted around the outside. So notice that the picture is given to us as an 8 by 5 picture. A mat of uniform width is going to surround the frame. This uniform width is very important. We don't know what the width of the mat is, so that's an unknown value. but we know that no matter where it is, it's always going to be the same distance, whether it's here, 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 or anywhere around the edge of the picture. Since we don't know what that is, we're just going to call it x. So now we can start to see what's happening here. The key to this problem is understanding what the 154 inches square actually represents. It can represent a whole bunch of different things, so we've got to make sure that we're clear on what it is. In this case, it is the area of the picture and the frame together. So that essentially is the area of the large rectangle around the outside of the entire picture. So we're going to utilize that. Now, meaningless information in this particular problem is going to be the area of the picture itself. 40 will not be used at all, even though we can easily determine what the area of the picture is going to be. So instead what we've got to do is we've got to figure out how long and how wide this picture is with the mat attached to it. So we're going to go ahead and measure from this edge to this edge. From here to here is x, from here to here is 8, and from here to here is x. So that means it's going to be 2x plus 8. Likewise, from here to here is x, from here to here is 5, and from here to here is also x. So this one is 2x plus 5. And now you can see how quadratics plays the role here as we find our equation of the area length times width. Using substitution, 2x plus 8 times 2x plus 5 equals 154. Using the distributive property, I'm going to go ahead and multiply this out. I get 4x squared plus 10x plus 16x plus 40 equals 154. To get this in standard form, I need to move the 154 to the left side of the equation. And now I get 4x squared plus 26x, combined like terms, minus 114 equals 0. Go ahead and factor this out, and once you do, you will find your solution. So pause the video now and see if you can get to your answer. Alright, now that you've gone ahead and done that, you should have come up with the positive value of x equals 3. And with x equaling 3, that's going to be your border of uniform width. That is going to be the width of that mat. Quadratic problem solving can be a little bit tricky, so please make sure that you get all of your questions answered in class tomorrow.